Hello, I'm Winston, and I'm a huge fan of the LambdaConf. As a politician, I fear the rise of AI and its potential detrimental effect to democracy. I'm therefore very happy to present to you today my dear friends Thomas and Martin with their fabulous talk about the AI election, how technology could shape public sentiment. Please welcome them to the stage.
Hello, LambdaConf. It's nice to be here in East Park, and welcome to our keynote today. The AI elections, how technology could shape public sentiment. Yeah. Before we start with our talk, we typically introduce ourselves.
Yeah,
Thomas.
But I think we already had the introduction. Right
yeah,
now,
right.
So,
but maybe a bit more. Yeah.
Yeah. No, I think we'll skip through that, and we'll just have a look at one video that we did with German television back in the days. This was 2021, and we already thought about, so we had created our first real-time deepfakes implementation, and we did some show with Harald Lesch, who is a famous German science guy, so comparable to Neil deGrasse Tyson in the US. And back then we already asked, what can we do with real-time deepfakes? Let's have a look.
Guten Abend zusammen. Willkommen bei Lesch Kosmos. Unser Thema heute Deepfakes, eine Technologie, mit der man praktisch jeden alles sagen lassen kann, und zwar in Echtzeit.
Das klappt ja wunderbar. Mit dieser Technik kann ja jeder eine Wissenschaftssendung moderieren, sogar du.
Ich und eine Wissenschaftssendung? Was für eine absurde Idee. Aber wenn meine Stimme da nicht wäre, dann könnte man mich wirklich für dich halten. Und überleg mal, wenn man das woanders einsetzt, dann kann man damit ja eine völlig neue Dimension von Fake News schaffen.
Und das macht mir echt Sorgen. Die Möglichkeiten zu manipulieren sind damit ja schier unendlich.
Ja, man könnte zum Beispiel irgendeiner Politikerin oder einem Politiker irgendwas in den Mund legen. Also was ganz Fieses. Und eine andere Regierung nimmt das dann ernst und drückt vielleicht auf den roten Knopf.
Wie so oft waren andere schneller als du und haben genau das gemacht.
Yeah, others did exactly that. Back in the early days of the Ukraine war, there was a deepfake of Volodymyr Zelensky asking the Ukrainian troops to lay down their arms and surrender to the Russian army. And this happened, when this happened, we were astonished and at the same time terrified, because technology like deepfakes could be used in a very, very terrible ways. We are not fans of that. Obviously, we did not create them. But nevertheless, we wanted to make the publicity aware, or the public aware of that. And we keep it like Carl Bergström from the University of Washington there, who said, when a new technology like this comes along, the most dangerous time in history is when it is out there, but the public is not aware of it. And this is the time when it can be used most effectively. So we wanted to show you what is possible with today's technology today and what this means. So Martin, what does it mean?
Yeah, so everywhere there are warnings issued about the dangers of AI, the end of society and everything. So actually AI was already somehow used at a Cambridge Analytica scandal, for example. 87 million data sets were harvested without the consent of the people, and they create psychographic profiles to find people who are easily to convince to vote for a specific person. So why is this currently a thing, the topic today? Half of the world's population has elections in the year 2024 and the beginning of 2025. Let's have a look to that. So the US is voting, the European Union, India, and the UK. And we're living in times where false stories spread 6 times faster and reaching 1,500 users compared to true stories. This is a fact from the MIT study, which was made back in the days in 2018. somewhere. And the question we ask ourselves, or in this round today, is, are we doomed in a world dominated by fake news? Yeah, so this is the question. And beside this, I have another question. Let's have a look to this image here. Okay, Donald Trump. This one here, Angela Merkel, Obama, Boris Johnson. What do these images have in common? Or this one here. This is also Boris Johnson. These pictures, if you won't believe it, but they are all real, except one. Did you recognize the faked one? It's the one with Angela Merkel and Barack Obama. The others are real, believe me. So how can you create such pictures today? Well, it's easy. For example, text-to-image AI, like Midjourney, Stable Diffusion, and stuff like that. You can type in a prompt like an oil painting of Angela Merkel. Or here we have the Pope Francis wearing an extremely puffy white down jacket in the style of Balenciaga, street photography. And there is one more. Barack Obama winning a dance battle against the super devil in a moody black hip-hop club mosh pit with cinematic lighting, 1920 colorized. As you see it with text-to-image, you already can create situations with people which never happened. Let's have a look to the agenda today. We want to talk about real-time deepfakes, showing a lot of demos today, a social media AI creating shit postings. We want to discuss audio deepfakes, and after all, we want to discuss possible countermeasures to fight against fake news. The AI timeline, it's a long story. 1966, Joseph Weizenbaum was implementing the first chatbot somehow, Eliza, which was quite good, but not compared to nowadays technology. 50 years later, deep learning, a paper in the University of Toronto was published, and then there was an explosion of AI apps. And before we continue right now to real-time deepfakes and how they work, we need the basic understanding of deep neural networks. So, Thomas.
Yep, so this is going to be really quick, but we'll run through the topic, starting with school actually. So you probably have seen such a picture in your school books someday. There's a human neuron, and the human neuron basically communicates with other neurons using electrical signals through the dendrites. And what it normally does is it just collects some stimuli, and if the stimuli are high enough, then we have a so-called action potential, which fires the neuron, and the information goes on to the next neurons. And if it's not high enough, then we have a failed initiation, and if that happens, nothing happens at all, so there's no information transported to the next neurons. So it's basically a 0 or 1, so cutoff function, someone might say, and that's why some intelligent mathematician then put this into a mathematical model, which is our artificial neuron. So here we have the input information, x0. This gets weighted by some weight omega 0, and then we add some bias, which basically tells us how reactive the neuron is. We put that through an activation function, so this could be something like a cutoff function, so 0 or 1 in the end, and then the information gets forwarded to the next neuron. And we also created a small animation about that, so the higher the weight is, the more important the information somehow is. Then we add the bias, we put that through our activation function. So in this case, it's not a cutoff function, but rather a rectified linear unit, which is basically just a linear function. And then the information is just forwarded to the next one. And now that we have this out of the way, let's have a look at a picture and how could we represent this picture for the neural network. So this is a grayscale picture, of course, and now we could just assign some numbers to the different values of the color. So a white might be a 1.0, a black might be a 0.0, and everything in between will be everything in between. And now we use the pixel grid. We just assign these values to each and every pixels. And then we could, this is as a basic first version, just use the pixels 0 to 19 as the first pixels of an input vector, then use the second 20 pixels, and so on, and just put them on one long input vector, and this will be our input vector for the neural network. And then we have typically some layers. So here we have a fully connected neural network, which basically means that every neuron of layer 1 is just connected to the input vector, and then every neuron of the layer 2 is connected to every neuron of layer 1, and so on and so on. So the information gets propagated through these neurons here until we finally reach our output layer where we deduce some information from that. In our case, we now want to show if this is a face, or we want to classify if this is a face or not. And here we see the output value is 0.89, which means that it is a face with a likelihood of maybe 89% or something like that. And if we put something in that is not a face, we could have something like a picture of a duck, just propagate it through, and ideally we will have something like 23% or a low number actually.
Yeah.
But Martin, what happens if it actually identifies this as a face?
There are situations where a deep neural network gives us information which is probably not correct. Like here in this case, now it's telling me, okay, 82%, this is a face, which is obviously wrong. And our typical reaction is something like that. And this means we have to do something. We have to do some fine-tuning, retraining, whatever you call it. So what does it mean to train a deep neural network? What do you have to do? Yeah, you have to punish the deep neural network. And you do that like you do it with humans, with money, with costs, with the cost function in this case. So you have your labeled training data, and then you can see, yeah, it's labeled with is face 100%. We know that. We put that into our deep neural network, and it says, yeah, 82%, very fine, very good. What you can do here is calculating the loss function or cost function, and you subtract the 1 minus the 0.82, then you square that, and then you have a very small cost function value here. And now let's have a look what happens if our deep neural network says, yeah, the duck is also a face, yeah, with the same numbers. So in the training data we have is face 0, of course, because it's not a face. But it's telling us with 82% that this is a face. And now let's have a look to the formula here, and you can see the cost function is much higher. Why do we tell you that? Because you can use this function to optimize your model, yeah, those values. So you put something in, you expect an output, and the difference between is our cost function value, and with this you can optimize the method. You use an optimization method like gradient descent, and you optimize the model with it. So speaking about synthesizers, just think about it. So you have some sequencer knobs. You can turn them, yeah? And you manipulate the weights and the biases. But the problem is, in a deep neural network, there are millions, if not billions, such knobs. So you normally don't know what will happen if you turn some weights and some biases. And yeah, so it's like a big machine, yeah, with extreme many knobs. And typically you solve that with mathematics, right? Yeah. Okay. And
right. With that out of the way, we have our first live demo. So this is a classification demo. So we classify whether the image is something like a lab coat, maybe,
yeah,
or
maybe a
bottle of water.
Yeah.
So here you can see, first of all, yeah, it shows a water bottle. So this is VGG19, a classification network. And maybe, Martin, you want to get into the screen a little bit more. So yeah, now we see a lab coat. Of course, Martin has a Windsor tie on. And yeah, some things, some other things as well.
Yeah.
So with that out of the way, now we have the theory on our backs, and we can dive right into our first topic, which is real-time deepfakes, of course. So first of all, what is a deepfake? So you take the picture or a video of a person, and then you replace the face, while at the same time, the facial expressions should stay the ones of the original person. And this is exactly what happens here, also in real time. So you see Harald Lesch on the right, but you also have Harald Lesch on the left. And only one of them is real, the other one is Dirk Steffens. And to be able to do this, we have to do a lot of different steps, actually.
Yeah.
And Martin,
let's go through those
what are the
steps.
first
The first step is the most boring one. We just need a video frame from our camera here. And then we make use of something interesting. This is MediaPipe, the face mesh. So we do some kind of a face recognition. And with this open source framework library, you can identify up to 468 points in the face. And as a demo tells us more than 1,000 words, the next live demo. And this is here. Thomas, maybe you want to tell something about it.
Yeah, so here you can see the face mesh adjusted to Martin's face. So it will recognize, it will recognize things like the eyes, the mouth, the nose, and so on and so on. And even if Martin is turning to the left or to the right, you can still see it works pretty well. Not perfect, but pretty well. And with that, we can now deduce where the face is located for our next step, Martin.
Yeah, the next step is the so-called face segmentation. Now we want to identify each and every pixel which belongs to the head, including the ear, the hair, if available, and everything. And again, we have a demo for this.
Yeah, so actually this demo was trained by ourselves. So we just used a hand-segmented version of celebrities. So some guy really took the faces of celebrities and pointed out where the face is located. And with that, you can train a neural network to do exactly that. And now you can see Martin in blue, and his face gets highlighted. If he turns around a little bit, you can see that it's, again, not perfect. So the neck is not perfectly separated from the rest of the face. But this might also be due to the fact that celebrities really don't like to look sideways into the camera. Yeah, training data and so.
Okay.
All right.
The next step.
Once we have that, we need to eradicate the old face because you don't want the old face to shine through when you put on a new face, right? And therefore, there exist already some techniques. So you probably have heard of something called in-painting. In-painting basically means it's the same technique that you use to restore old photographs. So you basically fill the information that you don't have. So if you have some scratches, you just mark them. And the pixels from the outside will move into the inside a little bit, and it will look like as if there had not been a scratch at all.
I have a demo on that.
Oh, really? Okay, then let's show that. So here you can see, I like Martin much better that way. And as you can see, it is also not perfect. So you would not think that there was never a head there. The pixels get sucked in a little bit. But this is not important for us because we want to put a new head anyway. So the only thing that might shine through a little bit are the pixels on the edges of the face. So that's fine for us. It's good enough. Let's put it like that.
Yeah. Now we have to show a slide which didn't age well.
Yeah, exactly. So the next slide. We did actually a deepfake of Vladimir Putin back in 2021 when we still thought that would be a good idea. Because with Harald Lesch, we thought, hey, let's take someone who has a similar head shape, who is similar hairstyle as well. And yeah, that didn't turn out that well. So today we would take something like the future Prime Minister of the UK, maybe. Yeah, that would be better. Okay, but nevertheless, let's have a look at how deepfake really works. At the core of each deepfake, we have a neural network called an autoencoder. An autoencoder is basically something that takes an image as an input and tries to reproduce the exact same image, but using a neural network in between. What it does is it consists of two different neural networks, or two different types of neural network layers. So first of all, we have a so-called encoder, which basically takes the image and puts that into a so-called latent space representation. This is a compressed version of the image. So what it normally will consist of is things like, so this is trained, so we don't really know, but it could consist of things like, is the mouth open, are the eyes open, is the person smiling? So things like that might be in the latent space representation. And after that, we use a decoder to take the latent space representation and get it back to an image. But unfortunately, if we start anew with a newly initialized network, we basically just get random noise, right? So what we have to do now is we have to calculate a loss function. This is pretty easy. We can just take the difference in the output image and the input image. So we can just do a pixel-wise comparison of these images, use that as our loss function, and with that we can train the neural network, and then we can reproduce the exact same image. So now we have a neural network, which takes a lot of electricity to recalculate the exact same image from an image we give it.
So wait, Thomas, you put in a picture of Harald Lesch, and the same picture will be the output.
Yeah, exactly.
That's really boring.
No, it's not. Okay, it's boring. But there is a trick in it. So if we take two autoencoders, actually, one for Dirk Steffens and one for Harald Lesch, then we can do the following trick. We take the picture of Harald Lesch, we put that through our encoder, then we have a latent space representation. Again, things like, is the person smiling, and so on and so on. And then we use the wrong decoder, so the one for Dirk Steffens, to reproduce the face of Dirk Steffens, but with the facial expression of Harald Lesch. And with that, we have created a deepfake.
A real-time deepfake in this case.
Yeah, because we have a demo for that, of course. So here you can see Martin, or you cannot see Martin, because this is Brian, from the spokesperson of Fujitsu. You can let him do stupid things. One thing that everybody does once they stand in front of the camera is they put out their tongue. But nobody actually does that for the training material, so the neural network does not really know what to do with it and tries to come up with something that seems logical.
It's comparable with Angela Merkel smiling.
Yeah.
So you can switch through all those faces. We have 4 of them here, so I can also switch my gender if I like. And this is how a real-time deepfake works. And it's running on our machine here. Thomas, which graphics card is there? NVIDIA 4090?
Yeah, there's an RTX 4090 in that, but it also works with a 2070 or something like that.
Yeah.
All right.
So, and as you might imagine, you can use this as for a cybersecurity attack. You can do identity theft and stuff. And actually, a few weeks ago, a deepfake leads to 25 million loss in a Hong Kong-based company because someone was within a video conference where 12, I think it was 12 people were deepfaked within this video conference. And you might say you saw the real-time deepfakes, right, the demo, and it was somehow recognizable that there is something, some artifacts in the face and stuff like that. But imagine if you are in a video conference, all those video signals that get compressed and decompressed and stuff like that, and you probably will not recognize that in a video conference.
But we tried that, Martin.
But we tried that actually with another German television company, so Pro7 and their magazine Galileo. So we have Haro Füllgrabe, the man with the hair, in front of the DSLR camera. The signal goes into our desktop PC with our deepfake software, and within the video conference, he appears as a bald man, Matthias Fiedler. So the setup works like this. Haro Füllgrabe, in front of the camera, he appears as Matthias Fiedler in the video conference, and the idea was to call the best friend of Matthias Fiedler. And now let's have a look what is happening.
Hallo, Richard! Du glaubst gar nicht, was hier alles los ist. Die Leitung stimmt nicht, dann geht das in die Hose und das geht in die Hose und das klappt nicht.
Die erste Hürde ist geschafft. Der Chatpartner schöpft keinen Verdacht. Dann gehen wir einen Schritt weiter. Haro alias Matthias schickt ihm eine Datei.
Okay, so Haro appearing as Matthias Fiedler, sends Richard a file. So the question to the room, what do you think? Will he open that file? Hands up. Who thinks he will open the file? Okay, a lot of, okay, perfect. We want to solve that question. Let's have a look.
Sein Gegenüber öffnet das Dokument ohne zu zögern. Gefährlich. Im Fall eines echten Betrugs könnte es sich um einen Virus handeln. Richard tappt in die Falle.
Ja.
Hast du es bekommen? Jetzt habe ich es bekommen.
And by the way, in this social experiment, this was not the only trap. There was another asking for transferring money, and he actually did it. So this is a real thing. Okay, but there are still possibilities how to identify deepfakes, and we want to have a look on that.
Yeah, because we have not seen enough Putin today, let's have a look at that. Here you can see Harald Lesch on the left, then the media pipe, a face mesh in the middle, and Vladimir Putin on the right. And we will have a look at could we spot such a deepfake.
Yeah. In this case, we have to say this was recorded under controlled TV set conditions. So you can expect a quite good quality here. But let's have a look how to spot real-time deepfakes in your daily life.
So as you can see, on the left side and compared to the right side, the level of skin detail is not as good on the right side, right? So you could still see that there are maybe a bit of distortions in the face whenever Putin is blinking, or also a lack of emotion because we did not have enough training material. You could also see some artifacts, namely maybe a few things that we have from the in-painting, and so on and so on. Apart from that, you could also see everything which seems a little bit unnatural. So for example, if you have a look at the beard, this is a bit unnatural that someone would not shave the neck but shave the face or something like that. Maybe it's a new style, but yeah. But also the hair and face, the hair and teeth, they are really hard to reproduce for deepfake. But nevertheless,
these are current limitations.
Yeah.
So it can happen that in a few years, everything of these problems are somehow solved, if you want to say so.
Yeah, absolutely.
Okay, so enough about deepfakes. Now we want to go into the social media AI. So we made our research, how to say, we went to the press and told them, hey, we are able to do real-time deepfakes. This was, we were the first company doing this. And the problem is, cool showcases can cause uncool responses. Yeah, so you know those shit posts from trolls and stuff like that, yeah. And this is a typical social media comment, yeah, which was dedicated to our deepfake thing. The employees at TNG Consulting cover the cam with tape on their notebooks. How do I know? Because everyone does it. I still think that maybe we have been unfair to the Amish people. We do not know what this has to do with Amish people, but anyway, this was
real-time deepfakes.
Or with real-time deepfakes. But our typical reaction is this one. Yeah. So just answering those comments, and then we thought maybe we should have a look from the outside the box.
Yeah, we need a model for that.
So we modeled this into the so-called shit posting cycle. And it consists of two parts. So we have on the one side the troll writing a shit post, and then you can see the average TNG consultant here, and he reads this shit post and is replying to that. But the problem is, this is a never-ending cycle, you know? And we thought, maybe we can take ourselves out of that loop so that we can work hard, party harder. Yeah? So we just have some kind of an AI answering to the shit posts, and we're completely fine. But wait, we can go a step further.
Yeah.
What?
Because in the end, the troll is also wasting his time, right? So we could also take him out of the loop so he could actually learn something sensible. And then we have this floating NLP brain just blathering all the way, all day. And everybody's opinion is recognized, actually.
Somehow, yeah. So, yeah, you're laughing, but studies tell us that from the Imperva study, they say, or they found out that the amount of automatic generated content by bots is at 47%. Other studies say it's approximately 75%. It depends, which study you actually read, but there are quite a lot of bots on its ways in the internet. Okay, so generating text. So how do we put text into numbers so that a deep neural network can work with it?
Yeah, so we need numbers again. So normally text is represented as a number of words. So computer science is so nice is our example sentence here. So what we could do here is we could just take every character that we have and encode that. But this is not what we want to do here, and this doesn't work that well. So normally what we do is we take it word by word. This is a very simplified description of everything. So in reality, it's much more complicated. But let's say we have the sentence, then we take it word by word, and then we just assign a number to each of these words. So for example, Martin, could you go a little bit further? Next slide, please. Okay, so we assign computer to the number 42, and so might be the number 3, and so on, and so on. And then we have a string of different numbers that we could then feed into our neural network.
Yeah. So this is probably the most boring demo right now. I have an example sentence. LambdaConf is a very, very nice conference. I create the output, and yeah.
Yeah, and as you can see, it's not every word, but sometimes it's also parts of words, because lambda might be not the most common word in the English language, and we don't want to assign like 1 million different tokens to each and every word that possibly could exist. And in German, we also have things like Donnerdampfschifffahrtskapitänsmütze, which is also a word in Germany, actually, and one word, so we don't want to assign a number to that. So basically, it's also, we just assign different tokens to parts of words. All right, and with that we can now fill our input layer. So we just take the input ID, the token IDs that we just have. So now we have 42, 23, blah, 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 blah. And put this into our neural network, into our input of our neural network. We also somehow have to fill in the gaps. So normally the sentences are not the same length. So we just pad them with some token, which is basically a padding token telling the neural network there is nothing in there. And we have a fixed length of our input vector. Some of you might also recognize that as the context length, which has been very popular with large language models in the last few years, actually.
Yeah.
And with that, we can now just put it through our neural network. Again, this is very simplified. And then we might get, for example, a next word prediction and predict the next token that is likely to happen.
Yeah. So what did we use for our shitposting AI? Yeah, we used, which surprise, GPT. So what does it mean? Generative pre-trained transformer. So generative means it is generating text. Pre-trained means it is trained on data from the internet, from books and stuff like that.
So it must always be right.
Yeah, yes, of course. And transformer, this is a very specific architecture in large language models. And the secret sauce of such a transformer is attention. So attention, what does it mean? So let's imagine you're in school, and you're writing a test and you didn't practice for the test. So what do? Yeah, you look around, trying to gain information, cheating, and so on, like in this picture here. And we have an example for that.
Yeah, so you basically look around and gather the information, just collecting the relevant one and bringing that to the paper.
Yeah.
This is also what attention
is,
right?
Right. So let's imagine we have some text and there is this token he. Yeah, but he, who is he? Yeah. Then we just have a look back into the text, like here, the shit poster is mad, he, blah, 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 blah. And what we can do right now is looking around, looking for the most important tokens here, which are important for the context. Yeah, And this could be, for example, the shit poster and he, of course. Yeah. So very simplified here in this case. And for the shitposting AI, we use GPT-2. Why? Because back in the days, it was open AI and not closed AI. So you were able to download GPT-2 and you were able to fine-tune it, to retrain it, and so on and so on. And we made use of that. And how does it work? Let's imagine your input is computer. Then you use this token as input. It goes through GPT, and the output is, for example, science. Yeah, next word prediction. Yeah? And then you put that science back into the input vector, and then you can see computer science is, and again, is cool. Cool. And then you do that as long as there is no end of text token. Here in this case, we have an end of text token, and we are now finished with the creation of our text. Yeah. But now the problem is, if you just download GPT-2, it probably will not generate shit posts out of the box. So this means you have to gather training data, right?
Yeah. And back in the year 2021, this was really a good year, we collected some data because it was still possible to scrape data from social media platforms. And we thought about, hey, what's the most hateful
platform? And this is the question to the audience. What do you think? Twitter? What? Oh, you're so good. Awesome. But we didn't gather all the texts and tweets and stuff like that from everywhere, so we just had a look to different channels. Like, for example, speaking about Reddit, it was Change My View, where we expected more differentiated opinions, or shower thoughts, Not the Onion, political discussions, or the most controversial forum was mechanical keyboards. Yeah.
All right. And with that out of the way, now let's have a little live demo of our final shitposting AI. You remember they shut down the API at some point because everybody was doing what we were doing. Nowadays we cannot get new opinions of things like that, so we are still stuck in the year 2021. COVID is a thing, so let's put exactly that in and see what our shitposting AI is producing.
You can get waxed or not, and the risk of hospitalization from it isn't worth the risk. It's not the vaccine. It is not for people to have access. So actually, we have been at conferences, at one conference where we had to stop the shitposting AI because it was getting really, really weird. And we didn't want to run into problems.
This is also kind of interesting. It creates fake Twitter links. So you cannot get anywhere with that link. At one point, it was even creating an iframe, and we were like, what is happening here?
And with this, you can, you don't need to write your own comments,
Yeah, exactly. But Martin, nobody's going to believe that, right?
Yeah, so, that's true. So false news on Twitter, again, from the MIT study, the source is in the upper corner there. False news on Twitter are 70% more likely to be retweeted than true stories. So the question is why? It's the human's preference for novelty which drives the speed of false news. It's not bots. That's maybe a bit surprising, but it is what it is.
Yeah, but if you think about it, if you read something that is new, that is fresh, you have to share it with the world, right?
Yes, you are informed sheep.
And you don't always want to fact check everything that you read. It might be quite, that's just what happens.
So now we have the real-time deepfakes. Yep. We have shitposting AI. What about audio?
Yeah,
audio deepfakes.
So now let's see what let's hear what audio deepfakes can actually do. So we've created a few.
Don't tell who's the guy just speaking right now, but let's have a look. Just a demo.
Positive thinking can be contagious.
Who is that?
Positive thinking can be contagious.
That's Schwarzenegger.
So
yeah.
is this a real audio or is it a fake
Positive
one?
thinking can be contagious.
Who thinks this is real? Really? Okay.
Positive thinking can be contagious.
Okay, we solved the puzzle. It's fake. It's fake. We try another test.
The more you temper a sword, the stronger it becomes.
Who thinks that this is a fake? A lot more people. That's
The
interesting.
more you temper a sword, the stronger it becomes. The more you temper a sword, the stronger it becomes.
So actually, this was published on his media channel. So, and this is
Could be a deepfake, right?
It could be a deepfake, yes, yeah. But I did my research. It's true. It's not fake. Okay. So, but how does that work, Thomas?
Yeah, how does that work? So the architecture of such an audio deepfake is pretty similar to what we saw before. So we have an encoder, we have a decoder. This all works also with a transformer architecture. In the beginning, the input is now not the tokens that we have, but rather the characters of that sentence you want to have spoken out. And with this first prediction network, we basically put out a MEL spectrogram. A MEL spectrogram is basically, it tells us which frequency is happening at which time. And then we can use a simple vocoder to put that into a waveform. And with that, we finally get our audio deepfake. And we can also train this to be a multi-speaker deepfake or a multi-speaker audio deepfake so that we can use one neural network to train multiple speakers at the same time.
Yeah. So now you are aware of all those different possibilities how to fake things. If it's graphics, if it's text or whatever. So now we want to talk about fake detection. So what can we actually do? Yeah. So what we did was the following. We just extracted a frame out of our real-time deepfakes, and this is a quite good one, right?
Yeah. This is absolutely not fake, right?
Yeah. So Thomas has two heads, like always. He's working for two people. And what we did was just taking available software claiming to identify deepfakes. Sometimes it's just claiming, nothing else. And then you have something like this. Yeah?
So this is 0% suspicious. So this must be true.
Yeah,
so
0% suspicious.
This is not a deepfake.
But there is software available which is much better. So have a look at this one. Yeah. So it says 0.001% suspicious. Yeah. So at least it's much better than the thing before. Yeah. We did a lot of tests. So with our experiment, we tried roughly 10 products, something, and let's have a look to this one.
Liebe Mitbürgerinnen und Mitbürger, ich wende mich heute an Sie, weil unser Land einer schweren Bedrohung ausgesetzt ist. Einer Bedrohung, von der wir...
Yeah, so again the question, what do you think? Is this a deepfake or is it real? Olaf Scholz, our chancellor? Fake? Fake? Okay. You're quite good. You're quite good. Let's have a look what the software said. So it said 62% suspicious. So the thing is, this is really a deepfake again. And you know, if you use such software trying to tell you if something is a deepfake or not, from our point of view, it has to be 100% correct. It doesn't help you if you have an outlier of 1 out of 100 videos or something like that, because this could be also problematic if you have a real footage, but some software states it's faked.
Yep.
Yeah.
And we actually did this not only for the video deepfakes, but we also tried some software for audio deepfakes, for detecting fake text, and so on and so on. So the output for audio basically was, if it's deepfake that was made with inferior material or which was not that good, it could really detect if it's a deepfake or not. But then again, if you can hear it anyway, so you all heard Arnold Schwarzenegger talking, and most of you recognize that this was not his real voice. then you don't need software for that because you can already hear it.
Yeah.
So, and the same is true for text. Even if it's got redacted a little bit, you could never tell the difference using the automatic software. So basically, yeah.
You can also flip a coin to.
Yeah, you can
like
flip
this.
a coin, and all the detectors that we tested, they were not really good.
Yeah, but let's go away from AI in this case. So actually don't need such high-tech solutions like deepfakes and stuff to fool people. There are low-tech solutions available, like a shallow fake, for example. So this is a story which went viral, probably especially in the US, I don't know, but at least in the Europe. Nancy Pelosi. Let's have a look to the following video footage.
We want to give this president the opportunity to do something historic for our country.
We wanted to give the president. Yeah, sounds a little bit drunk, right? What is the problem here? Let's have a look to the original video.
We want to give this president the opportunity to do something historic for our country.
So what happened here? What happened here? This is the correct answer. Yes, it was slowed down. Now you can see the verified video on the left and the altered video on the right. And you can see that the altered video is slowed down. But wait. If you slow down a video, what happens? What happens then? The voice will get deeper.
I want to give this president the opportunity.
Yeah, this doesn't sound like Nancy Pelosi, right?
For
so
our country.
It's really easy to solve this problem. You just pitch up the voice track here in this case, and then it sounds like Nancy Pelosi again, but somehow drunk. Yeah. Yeah.
We want to give this president the opportunity to do something historic.
Yeah.
Okay, so but not only shallow fakes are a thing.
Yeah, and even if you just frame some information in a specific way by narrowing down the information or putting it somehow in a different context or something like that, you can still do a lot of bad things in this world because basically nobody will fact check what you did. So for example, let's have a look at the out of context information.
Yeah.
And here you can see
Hyde Park this morning, the eco-warriors, Extinction Rebellion have left their plastic, rubbish, and everything.
Yeah.
But the funny thing is, this isn't actually the Hyde Park. Yeah.
Yeah, and it's probably also not the trash of the Extinction Rebellion.
That's
group.
correct as well.
Yeah.
So let's have a look to our conclusion right now.
Yeah, so there are a few things you should consider when dealing with information in general. So please always consider the source. So hands up who was trying to fact check what we just told you with our different, with our different.
We just mentioned some studies, right?
Yeah. So one person was actually trying to fact check that.
Okay.
Perfect. Yeah, this is exactly what you should do. But you can also check the author. So is the author a reliable source or something like that? And you can then go into the supporting sources, read about them, and so on and so on. So this is one important aspect of all of that.
Yeah. And another specific thing is, clicks are a currency in the internet. So read beyond. Yeah, they always try to do clickbaiting. Yeah, so it's always a good idea to read the whole article. Check the date. Yeah, it is possible that a story was just reposted, and it doesn't mean that it is relevant to our current situation. Yeah, and as well, you could ask yourself, is it a joke? Because sometimes things they sound too outlandish, and if it sounds outlandish, maybe it's just satire. You never know.
Yeah, and then again, you also have to check your own biases. So if something sounds exactly like, trying to put out your point of view, so basically just reassuring you in what you already know, then you are more likely to just support this. So, but you should also check in case you think that it is true.
Yeah, these are points from the International Association of Librarians. And they always used to ask, said, yeah, and of course you can ask the expert, right?
Yeah.
With the lab coats, that's clear. But we see that there is another problem. This is our personal point of view here in this case. So we see the problem is in current media consumption. The attention span is very, very low, just for only a few seconds, if you use TikTok, Instagram, and stuff like that. And here you can see a woman having her mobile phone, and she is looking to a picture of a father in the Gaza war zone with 5 children. This story also went viral. And now imagine you see this picture for, let's say, 5 seconds, and you made your decision to like it, yeah, so that it gets retweeted or whatever. But did you recognize something? There is something wrong with this picture, yeah? So there are missing toes, missing fingers. There are unusual positions of the bones and stuff like that. So this is obviously generated with a text-to-image AI. But if you have your small display and just a few seconds amount of time, you give things like these a forum, and then they will went viral. And this is a problem.
Yep. Now that we've talked about all the bad things that can happen if you use AI, let's also talk a little bit about the good things that AI can do, because we have a dual use dilemma here. And an AI that can generate fake content like our real-time deepfakes, they can also create things for the good of humanity. And we used a part of that for this showcase here. So this is basically a GDPR-compliant security camera, and we used it for real security cameras, and we used exactly the same segmentation network that we also used for our real-time deepfakes to create something which is just heightening the privacy of people. So everything can be used for the good and for the bad in this field. So.
Yeah. So we hope we gave you some inspiration how to fight against fake news. You are now aware what's possible today. Spread the news, especially when it comes to your family members and stuff like that. They probably are not that deep in tech. I don't know. We don't know. And
check the facts.
And check the facts, right? And this is the end of our keynote. We hope you liked it. And if you have any questions, because we are running out of time, we will be here all the evening today. So just approach us and talk with us. And thank you.
Thank you.